To divide by a monomial, for example, here we see the denominator, there's no plus or minus, so this is just one term. So we can just separate the terms and simplify because all three terms in the numerator are getting divided by the denominator. So I can split up this single expression into three separate expressions, and they all get the same denominator. Okay, so over here, 6 divided by 3 is 2. R to the second power divided by 1r, you take 1r away, now there's 1r left. S to the second power, you take 1s away, there's just an s left over. 3 divided by 3 is 1, r divided by r again is 1, s squared divided by s is s. Negative 9 divided by 3 is negative 3, r squared divided by r is r, s divided by s is just 1. Okay, and then an example of dividing by a polynomial. Okay, so remember the divisor goes on the outside. Okay, so my goal is to make the x match this negative 5x to the fifth. Okay, so I can ignore the plus 4 for now, and I can ignore all of this over here. My only goal at the moment is to figure out what do I multiply x by to get to negative 5x to the fifth power. Okay, so that answer is negative 5x to the fourth power. Okay, but then now this, once I figure that out, it not only multiplies that x, it now does multiply this plus 4 as well. Okay, so again, I have negative 5x to the fourth, and I'm multiplying that to the x plus 4. Okay, so negative 5x to the fourth times x is now negative 5x to the fifth, and then negative 5x to the fourth times positive 4 would be minus 20x to the fourth. Okay, so I'm going to write that underneath. Okay, so as we know with long division, once you write the number underneath, you subtract it from what's above. So that's pretty straightforward when you're dealing with just constants, but when there's variables, it can get more confusing. Okay, so again, I'm subtracting this whole binomial. So the easiest way to subtract is to add the opposite. And just keep in mind, this, when you subtract, you don't just affect the first thing, you affect the second thing too. So again, to change the subtraction to addition, I need to switch every sign inside. Okay, so negative 5x to the fifth plus 5x to the fifth cancels out. That should always happen. The whole point of each step is to cancel out the first part. And then negative 21x to the fourth plus 20x to the fourth is now negative 1x to the fourth. Okay, bring down the next term, negative 3x cubed. Okay, so again, ignoring everything else, my only goal at the moment is to make the x plus 4, or actually really just the x, make this x match the negative x to the fourth. Okay, so what do I need to multiply x by to get to negative x to the fourth? I need to multiply it by negative x cubed. Okay, so again, once I've determined what goes up here, I multiply the outside by it. Okay, and then distributing, we get negative x to the fourth minus 4x cubed. Okay, write that below. All right, so again, in order to subtract this, I'm going to need to change my signs. So instead of subtracting, I add the opposite of the inside. Again, you change both signs. Okay, so negative x to the fourth plus x to the fourth cancels out. Negative x cubed plus 4x cubed would be positive x cubed. Okay, bring down the next term. Okay, so now my goal is to make the x match the x cubed, the positive x cubed. So x times what equals x cubed? It would be positive x squared. And again, I need to now distribute this to the whole outside. Okay, so again, subtract the whole thing by switching all signs. This is originally positive, so it becomes negative. This is originally positive, again, it becomes negative. Okay, so x cubed plus negative x cubed cancels out. 4x squared plus negative 4x squared also cancels out. Okay, so there's nothing. There's like a 0 if you want. Okay, bring down the next term. Okay, this situation is a little unusual because I have a binomial out here, so I need an equal amount of terms down here. So I need to bring down this second term at the same time. Okay, so again, because there's two terms out here, binomial, I need a binomial at every stage of my process. Okay, so lastly, how do I get from x to negative 2x? I must multiply by negative 2. Okay, and then negative 2 times x plus 4, the outside. We got negative 2x minus 8. Okay, in order to subtract, I'll switch the signs. Okay, negative 2x plus 2x cancels out. Negative 10 plus 8 is negative 2. Okay, so I've got no more terms to bring down, so this will be my remainder. And just like when you write your remainder as a fraction, you can, so I'll choose to write it with a plus sign. Okay, so my remainder is the numerator, and then the denominator is the thing you divided by. Okay, so here's your answer up here. Negative 5x to the fourth minus x cubed plus x squared minus 2 plus negative 2 over quantity x plus 4. Okay, so this first problem, square root of 128. So there's no index visible, but we know it's an invisible 2. So our goal is to create things to the second power inside. So I can rewrite 128 as 64 times 2. And then 64 is equal to 8 to the second power times 2. So now I have a term inside, which has an exponent matching the index. So I get to take just the 8 outside, not the 8 squared. The squared gets used up to break free of the index. So this 8 moves outside. This 2 does not have the correct exponent, so this 2 needs to stay inside. Okay. Another example, I'll do one with cubed. Okay, so this time the index is 3, so my goal is to make something to the third power inside. So 16 can be rewritten as 8 times 2, and 8 is 2 to the third power. Okay, so again, now that I have a matching exponent to the index, I can take this base out, and I have to leave this one inside. And don't forget the index remains the same. Okay, doing one with a variable. So here, again, my goal is to make things to the third power. I have m to the fifth power inside. So I'll split that m to the fifth power up into m to the third power times m to the second power. Okay, so this first part, this m cubed matches the 3, so I can take an m outside. But this m to the second power doesn't have enough to match the 3, so this m to the second power will stay inside. And again, keep the index. Okay, so let's look at this one over here. So again, invisible index of 2. Okay, so it's an even index, and so I've got a to the 20th power. So I know that a to the 20th power, I could make that a to the 10th power times itself. And similarly, b to the 19th power, I could make b to the 9th times another b to the 9th, and then I need one more b left over at the end. Okay, so then I have a to the 10th power times itself, which is the definition of the squaring it. And then same thing, this b to the 9th times itself, that's the definition of squaring. And then I have this one left over b. Okay, so this whole a to the 10th power has the correct exponent, so I can take it outside. Okay, so I do not need to put absolute values on this a to the 10th, because when it's an even exponent, right, if you multiply anything an even amount of times, it'll always end up positive. Okay, on the other hand, this b to the 9th, when I take it outside, if b was negative, when I do it an odd number of times, all the pairs cancel out, but then we got one negative left over. So we do need an absolute value on b to the 9th. Okay, and then what's left over, we just have this b left inside. Okay, so going back for a second, this one I did not need the absolute value because it's an odd root, or odd index. Okay, only if both situations are met. If the index is even, here the index was 2, and a variable to an odd exponent is moved in front. So b to the 9th power, 9 is odd, so since I moved this out in front, it needs the absolute values.